Hi, in this lesson I am discussing a few exam type questions in projectile motion, and the questions mainly focused on Edexcel, Cambridge and International Baccalaureate syllabuses, A-level syllabuses. Right, okay, the first question, a ball is projected from top of a building at a velocity of 9 meter per second in horizontal direction, and this is the path of the ball. During its motion, there's a point P at which the velocity is V. We don't know. We can find it. Velocity is V. That makes an angle 55 degree with the horizontal line. The horizontal displacement at point P is x. The first part, find the vertical component of the velocity at point P. Okay, so find the vertical component of the velocity at point P. We know that the horizontal component of the velocity is constant. Normally, we don't consider the drag force. So when we don't consider the drag force horizontally, we know there is no acceleration. So the horizontal component of the velocity will remain the same throughout the motion. So if I use that idea for the first part, I can say at P, the horizontal component of the velocity Vh is equal to 9 meter per second. But I know the velocity took it as V. So that means V cos 55 equal 9. So V cos 55 9, that's the horizontal component. So V I can find 9 divided by cos 55, that will be 15.7 meter per second. The question is the vertical component at point B. So the vertical component, I can say VV, which is downwards. Let's resolve it. It will be downwards. That will be V sine 55. That will be 15.7 sine 55. That will be 12.9 meter per second. Okay, the second part. Find the vertical distance through which the ball has fallen. So we found the vertical component at point P. So I can use second part. I need to find the time taken. Or I can use vertically V squared equal U squared plus 2s. For the motion from initial point, I can call it as x. X might give confusion. So I can say the initial position Q. So when I consider the motion from Q to P in vertical direction, so I can use V squared equal U squared plus 2as for the motion from Q to P in vertical direction. So I know the vertical component of the velocity. I found it just now, that is 12.9 meter per second. So 12.9 squared equal, initially it was projected horizontally. We know horizontal vector has no vertical component, so that will be 0 plus 2 into 9.81 into the distance it's fallen vertically. I'll call it as capital H. That's the height it's fallen, right? Capital H, I can make it. So solve it and find the H. You will get answer 8.48 meters. Third part, find the value of x. Okay, so for that I need time, because horizontal velocity remains unchanged. I need to find the time. So vertically use v equal u plus 80 for the motion from Q to P. So the vertical component of velocity at P, we know that is 12.9. So 12.9 equal initial velocity, vertical direction 0, because it was projected in horizontal direction. So 0 plus 9.81 into T, find the time. 12 divided by 9.81, it will be 1.31 second. Now use horizontally S equal ut plus half at squared. That also for the motion from Q to P. So x equal, the velocity horizontal direction remains unchanged, that is 9. So 9 into, the time is 1.31 plus half, acceleration horizontally 0. So that will be 11.8 meters. Okay, so this is the second question. So a ball is kicked from the ground, maybe a football, is kicked from the ground at a velocity of 18, at a speed of 18 meter per second at an angle of 32 degree to the horizontal ground. So it moved and hit a vertical wall in horizontal direction. That means during collision, the velocity of the ball is horizontal. It hits the wall in horizontal direction and bounce back and hit the ground again at point Q. So the ball was kicked from P. After hitting the wall horizontally, it's bouncing back and hitting the ground at point Q. The distance between P and Q is 4 meters. First part, find the time taken to reach the wall. Okay, so find the time taken by the ball to reach the wall. So there I can use the first part. I can find uh, okay, so the idea here, the ball is hitting the wall in horizontal direction. If that data is not given, we can't answer the first part. It's hitting the wall in horizontal direction means the ball is hitting the wall at its highest point. So the time taken to reach the wall is same as the time taken to reach its highest point, is it? So at the highest point, we know the vertical component of the velocity is 0. The ball is moving away from the ground and then it will start to move down. So at the highest point, the vertical component of the velocity will be equal to 0. So I'm going to use that one. So I can use vertically P equal U plus AT. So at the highest point, when it is hitting the wall, the vertical component is 0. Initial velocity is 18 sine 32 plus minus 9.81 because gravitational acceleration is downwards into t. Find the time. 18 sine 32 divided by 9.81. So that will be 0.97 seconds. Right. Find the height h at which the ball hits the wall. So there also I know the vertical component of velocity when it is hitting the wall is 0. So second part, I can use v squared equal u squared plus 2as for the motion from P to the wall. So the vertical component is hitting the wall is 0. Initial velocity is 18 sine 32 all things squared plus 2 into minus 9.81 because I'm using upward direction. Acceleration is downwards 9.81. So it should be minus into h. So bring it to the left. 19.62 h equal 18 sine 32 square. Find the h. So the answer h, the vertical height will be 4.64 meters. Okay, right. Third part, find the velocity at which the ball bounced back from the wall. So it's hitting the wall horizontally. So certainly it will bounce back in horizontal direction. Even if you think in terms of momentum, before hitting the velocity is horizontal means it will bounce back in the same direction, horizontal direction. So when it comes back and hits the ground, its vertical displacement is again the same as earlier what we found, 4.64 meter. So to complete this vertical displacement upward direction, it took 0.97 seconds, means to come back and reach the ground, again it's completing vertical displacement of 4.64, the time taken to reach the point Q from the wall, again the same time, 0.97 seconds, right? So I need to find the horizontal velocity at which it's bouncing back. The time is same as P to the wall and wall to Q, the same time. Okay, so first I should find the horizontal displacement when the ball was kicked towards the wall. I should find the horizontal displacement. I need to find the distance of the wall from the point P first. Okay, so I need to find the distance of the wall, horizontal distance of the wall from point P. So horizontally use S equal ut plus half at squared from point P to the wall. So I will find the horizontal distance. So that I can find it like 18 cos 32 into the time we found it 0.97 plus acceleration is 0 horizontally. So the distance will be 14.8 meters. Okay, so the distance of the wall from point P is 14.8 meters. So the horizontal displacement, the ball bounce back will be 14.8 minus 4, right? So I'm going to use horizontally again towards left is equal ut plus half at squared. So the horizontal distance this much, the ball bounced back, that will be 14.8 minus 4. That's the distance it's traveling horizontally. The velocity at which it's bouncing back, I can call u1 into the time is same. I already told that the time taken to reach the point Q after hitting the wall is same as the initial time. So 0.97 plus no acceleration in horizontal direction. So u1 will be 11.13 or 11.1 meter per second. Okay, so this is the third question. So there a ball is kicked from ground at a velocity v at an angle 28 degree to the horizontal. It hits the wall at a height h which is 24 meters away from the initial point. And the total time taken by the ball to reach the wall from the initial point is 1.5 seconds. First part, find the speed v. So find the speed v. Okay, so first part I can say I know the horizontal displacement, I know the time, I know the angle. So first part I can use horizontally s equal ut plus half at squared. S is 24. Initial horizontal velocity is v cos 28 into the time is 1.5 given. Horizontally no acceleration. Find the v. So you will get a value of v first part 18.1 meter per second. Okay, second part, find the height h at which it hits the wall. Okay, so the second part I can use vertically upwards s equal ut plus half at squared for the motion from initial point to the wall, right? So the vertical displacement is h at which it's hitting the wall, right? So I can find h is equal to initial vertical velocity. I already found the v, that is 18.1 sine 28 into the time is 1.5 plus half into minus 9.81 because I'm taking upward direction, A is downwards, gravitational acceleration, into 1.5 squared. Okay, when you solve this, you will get the height h. Answer will be 1.71 meters. Right. Third part, find the velocity at which it hits the wall. Velocity, because I need to give the angle, the direction also when it hits the wall. So when it hits the wall, the velocity will be along the tangent, something like this. I need to find that velocity. I can call v1 how much, and I need to give this angle theta. I need to find that one also. And we know horizontal component of this velocity just before hitting the wall remain same as the initial horizontal component, that is 18.1 cos 28 will be the same as here also the horizontal component because there is no acceleration in horizontal direction. So I need to find the vertical component of the velocity during collision. Okay, for that I'm going to use v equal u plus at in vertical direction. So I can use third part in vertical direction. Actually, I know when it is hitting the vertical component will be downward direction. When I use vertical direction upwards, I'll get negative answer. See, So use V equal U plus AT for the motion from initial point to the wall. So V I call it the vertical component, upward direction. So initial velocity is V sine 28. We know the initial value of V, which is 18.1. So 18.1 sine 28 minus acceleration is downward. So minus 9.81 into 1.5. Solve it, you will get that minus negative 6.22 meter per second. So upward direction I took it, I'm getting negative 1. So the vertical component is 6.22 meter per second downward direction. Just the vertical component of velocity just before hitting the wall. The horizontal component of velocity remains the same. The horizontal component of velocity just before hitting the wall, that is going to be 18.1 cos 28. That will be 15.98. I can take it 16 meter per second. Okay, so I know the horizontal component just before hitting 16 meter per second. Vertical component vertically downwards 6.22 meter per second. So this is going to be the velocity V1. The velocity V1 will be this one. This angle theta I need to find. So V1 I can find because velocity is a vector quantity. I can find the V1 by using Pythagoras theorem. So V1 is equal to square root of 16 squared plus 6.22 squared. Okay, that will be 17.2 meter per second. Angle I can say tan theta is equal to opposite 6.22 over adjacent 16. Find the theta. So 21.2 degree. Okay, fourth question in which a tennis player hits a ball at an angle of 8 degree downwards from the horizontal line at a velocity of 64 meter per second, and the ball was hit at a height of 2.9 meters above the ground. So the height of the net, the tennis net, is 0.91 meters, and there's a line on the other side of the player who is doing the service. On the other side, line called service line, which is at a distance of 6.4 meter from the net. So the ball during service should fall within the service line. Okay, so the first part, find the time taken to reach the net. Okay, so find the time taken to reach the net. Right, so the reach the net means here it's not hitting the net, it's passing over the net. So find the time taken to reach the net here means how long it takes to pass over the net. So the first part will be, we can see the first part, horizontal, I can use S equal UT plus half AT squared. So here careful, the question does not mean the ball is hitting the net. Okay, it's going to pass over the net, but to reach this vertical position, to pass over the net, the time taken, find the time taken to reach the net means the position of the net, right? Okay, I wrote the question shortly. It's not hitting the net, it's passing over the net, but how long it takes to reach the position of the vertical line, vertical alignment of the net? That's the question, right? Okay, is equal to UT plus half AT squared. The net is at a distance of 11.9 meters in horizontal. So 11.9 equal 64 cos 8 into t plus, you know, horizontally no acceleration will take always in horizontal direction, no drag force, no acceleration. So if I find the time will be 11.9 divided by 64 cos 8, that will be 0.188 seconds. So that's the time taken by the ball to pass over the net. That's the meaning of it. Second part, find the height of the ball above the net when the ball passes over the net. Okay, so I can find the vertical displacement of the ball when it is passing over the net. So I'll use vertically downwards S equal ut plus half at squared until it passes over the net. Okay, not hitting the net. We'll see how much, whether it's hitting or not. We don't know until we finish the calculation. We can't say. Right, so the vertical displacement will be downwards 64 sine 8, because if I resolve it vertically downward, 64 sine 8 into the time taken to reach the vertical line of the net is 0.188 plus half into 9.81. Yes, acceleration also downwards. I am also using downwards into 0.188 squared. Solve it, you will get the vertical displacement of the ball when it is passing over the net. Okay, so that will be 1.85 meters. It's vertical displacement, move down vertical displacement, 1.85 meters. Okay, so the question is find the height of the ball above the net. So the ball is moving maybe like this. So the vertical displacement, we know 1.85 meters. So we'll find its height above the net. Okay, we need to find the height above the net. Okay, so we can find like this. So we can find the height of the ball above the ground. So 2.9 minus 1.8, right? So we'll say height of the ball above the net we can find directly. Above the ground we'll find it first. That will be 2.9 minus 1.85. So that will be 1.05. So how much is it above the net? So above the ground 1.05. Height of the ball above the net 1.05 minus 0.91. So that will be 0.14 meters, or you can say 14 centimeters. So it won't hit the net. Okay, so third part, will the ball hit the ground within the service line? Okay, so the service line is at a distance of 6.4 meters from the net. So for that, we will find the total time taken by the ball to reach the ground. We know it's not going to hit the net. So we'll find the total time taken by the ball to reach the ground. So that means the time taken to complete a vertical displacement of 2.9 meters. Okay, so there you will get a quadratic equation. So downwards we use S equal ut plus half at squared. From where to where am I using? From the initial position to the ground. So when it reaches the ground, its vertical displacement will be 2.9 meters. Initial vertical velocity will be 64 sine 8 into t plus half into 9.81 t squared. So if you rearrange this equation, you will get 4.905 t squared. 64 sine 8, find it. That will be 8.91. So plus 8.91 t, bring it to the right, minus 2.9 equals 0. So it's a quadratic equation, right? Solve it by using calculator in equation mode. All of you know that how to solve it. Okay, if you solve it by using equation mode in calculator, so you can, most of the exams you can use calculator, Cambridge, Edexcel, and International Baccalaureate. So you are allowed to use calculator. So solve it by using calculator and find the time. You will get two answers. The first answer is 0.282 seconds, 282 seconds. And the other answer, I can call T1, T2, the two roots of this quadratic equation, that will be negative value, negative 2.10 seconds. So we know time is a positive quantity, so this is not acceptable. Negative answer is not acceptable. So we know the time taken to reach the ground is 0.282 seconds. So find the horizontal displacement during this time. Horizontal use S equal ut plus half at squared until it reached the ground. So that will be 64 cos 8 into the time is 0.282 plus no acceleration because no drag force we take. So the range will be, the horizontal range will be 17.87 or 17.9 meters from the initial position. Okay, so we need to find it from the net. How much is it? So from the net, the distance at which it hits the ground will be 17.9 minus 11.9. You will get 17.9 minus 11.9. Yeah, you will get 6 meters. That is less than 6.4 meters. Yes, the ball will hit within the service line. Okay, so that's a question. Will it hit within the service line? Yes, it will hit within the service line because distance at which it hits the ground beyond the net is 6 meters, but service line is at a distance of 6.4 meters, so the ball will hit the ground within the service line. Okay, so here X and Y are two curved tracks. A ball is rolled on it. So when the ball leaves a small marble, something like that, when the marble leaves the track X, its velocity is 7.2 meter per second, and it follows a projectile path and lands on the second curved track Y. Both are having the same height. Both edges X and Y have the same height. So the ball is landing on the same horizontal level. Okay, the distance between the two tracks, between the edge of X and the edge of Y, the horizontal distance is X. So also it given the horizontal component of the velocity is 5.6 meter per second when it is leaving the track X. So the first part, find the vertical component of the velocity when it leaves the track X. Find the vertical component of the velocity at X when the ball leaves the track. So first part, nothing. I know the horizontal component, 5.6. So they are saying horizontal component. I know that 7.2 cos theta, the angle at which it leaves the track X is theta. So VH is, I know, 5.6. That will be 7.2 cos theta. From this, find cos theta. That will be 0.778. So I need the angle theta, find it. 38.9 degrees, so I can say 39 degree. The question is find the vertical component. So the vertical component PV, I can say that is 7.2 sine 39. Find it. That will be 4.53 meter per second. Second part, find the time taken to reach the track Y from X. So it's completing projectile motion, right? I know the angle. When we consider the whole motion, vertical displacement will be equal to 0. Okay, so second part I can do like this. When we consider the whole motion from here to here, the vertical displacement is equal to 0 because both have same height, so it has come back to the same level. So I can say for the whole motion, consider vertically S equal ut plus half at squared. S is equal to 0. The initial vertical velocity is 4.53 into t plus half into minus 9.81 because g downwards. I'm taking upward direction into t square. I can divide the whole equation by t. So 0 equal 4.53 minus 4.905 t. Find the time. That will be 0.92 seconds. Okay, so third part, they asked to find the value of x. So the distance between the two ramps. Okay, so third part, the distance I can use horizontally is equal ut plus half at squared for the motion from edge of the curved track x to y. So x is equal to the initial horizontal component of the velocity 5.6 into the time we found it just now 0.922, horizontally no acceleration. Solve it. You will get the answer for this 5.15 meters.